In this lecture we are going to talk about pointers, even though the concept of the pointers was introduced to you in the previous module and when we were working with the assembly language. But in here I want to just talk about pointers in C and why we need them in general. So first we create a file, let's name it pointers.c, and since we want to use the printf function, I include the stdio.h, and this would be our main function, and we return 0 in here. First I want to create a variable, let's name it a, and I want to initialize the a variable with the value of 5. Then I want to print the address of the a variable in hexadecimal or in P format, which we talked about, then a colon, and then I want to print the variable itself in the decimal representation. You should know what this is by now. Then we want to change the variable of a, the content of it, and put the number 10 inside it. And then I want to do the print in here again. So I save it, and let me make sure we don't have any problems. Now I compile it using the GCC compiler, and we execute the program. And if you see, well, let me actually just put the \n so that we would go to the next line in here. Compile it again and execute it, and if you look, this address has been assigned for the a variable. A variable is just a placeholder, so this is the memory address assigned to it, and this is the value of 5. Then when we change the variable a, the number 5 has been overwritten by 10. You see, this is the same address. It seems like it would be better if we saved the address of a variable so that we could keep track of the values in it, or even if we want to change the values in here, instead of working with a variable, we could work with the address of a in here. So let us just find a way to save the address of variables. Well, for that we use the pointers, and actually this is the definition of pointers in C. They are just some placeholders for addresses, for memory addresses. So in here I just cut these lines, and let's say that I want to save the address of a variable, which is %a, inside the variable. For that we should define the pointers. So in here, because the type of the a variable is int, so I want to define an int pointer. Pointers are defined with the star and then the name of the pointer. Let me name it p. So I say int p, and in here we have defined a pointer, and I want this pointer to be equal to the address of the a variable. Now after that I want to just say print, and with the p format I want to save the pointer p. Also what I want to do is that I want to print the value inside the memory address that p is pointing to, but using the p and not a. If we want to do this, we say a star. This is for well, they call it dereferencing in here. By saying a star and p, we are telling the compiler that what is the address that p is pointing to, bring me the value of it. And in here we are telling it that print it in the decimal format. Now I save it, I exit, compile, or actually let me also put a \n so that we would go to the next line, save it, compile it, and execute it. And if you look, this is the pointer, which is just the address of the a variable, and this is the number 10, which is actually inside this memory address. And you see, this would be the address of the memory, just when we execute it again, another memory address would be assigned, but this is the address of a. If you want to make sure of that, you could just cut this line and do it in here again, and in here again. I shouldn't have wiped it in the previous section. So in here, if I say p and then d, this would be the ampersand A, this would be the A, and also the same thing in here, ampersand A and A, save it, exit, use the GCC compiler, execute it, and if you look, well, this is the address that has been assigned for the A variable. The content is 5, again address of the A, the content is 10. Then instead of working with 10 in here, we have created a pointer, we save this address inside the pointer, and we use the pointer to and actually let me also use the pointer to change the value of A. After this, you see, after we have printed, I want to use the pointer in here to change the value saved in it. So what I could say is to say a star P, which is the content saved in the memory address that P is pointing to, equal to 15. And after that, I just print it again. So in here, yes, we just print it again. And if you want to make sure that this is actually the same address, we could say P in here too. So you see, P is the memory address and a star P is the content in that memory address. Save it, compile it, execute it, and this is the memory address. You see, at the end, this is the same memory address and the content has been changed to 15. Now let's say also in here for the last part, I want to print the A also. So this would be ampersand A, and this would be A. You see, all of these things are the same thing. It's just different ways of showing it. In here, we are using the A variable. In here, we are using the pointer to manipulate the data. But you see, the output or the result of each one of these printf in here would be exactly the same thing. So I just go compile it and execute it. And if you look, this is exactly the same thing. Ampersand is saved, address of the A is saved in the P. We could just call it using the P variable, and a star P means the value saved in the memory address or the A variable. But what you are going to do is to use the GDB to step through it. In that way, you would completely understand what I'm saying in here.